So let's actually go through a few steps that we would take if we're trying to take the square root of trying to draw the square root of a function. So we're going to first start off with, the first thing we're going to start off with is y is equal to the square root of f of x. So if we get given an original function f of x, what happens when we square root that number? Okay, so here's a few steps that we have here, and I'm going to go through it and explain what happens. So we'll have a look in this box. To sketch the square root, r of x is equal to the square root of f of x. So this is what we have up at the top here. The first thing is to take the square root of ordinates whenever possible. So take the square root of ordinates whenever possible. So what this is telling us is, if the graph has a y value, if the graph has y values, so if we graph gives us a y value, we want to take the square root of those y values. So square root y values given. And I should have made this clear in the previous video, but we're doing this the same. This is exactly the same regardless of what graph we're doing. So last lesson when we did reciprocals, we wanted to take the reciprocal of y values. So for example, we did an example where we had asymptote at 2, and so when we took the reciprocal, that would result in 1 over 2 when we were taking the reciprocal. Here, if we have a y value in our original function of 2, if we're trying to take the square root, then that becomes square root 2. So if there are values that you see, if there are y values that you see in your graph, we want to take the square root of that. We want to take the square root of that and put that will be in our final graph. So that's what this first dot point here tells us. Okay, now systematic approaches. Let's go through each one of these lines. Okay, the first one, I'll do this in a different color. Delete everything below the x-axis. We want to firstly delete everything below the x-axis. Why is this the case? Well, if you have a look at my 3 conditions, everything below the x-axis corresponds to this row here. If it's less than 0, if the y values are less than 0, that means it's below the x-axis. So we need to delete all of those values. So if you see anywhere on your graph where it's below the x-axis, we're just going to ignore those parts. So this is this is for when y is less than 0. So because y is less than 0, we cannot take the square root. Square root y does not exist for those values. Okay, so that's the first dot point here. If we have anything below 0, we have to delete it. Okay, second dot point here. When f of x is equal to 0 or 1, r of x is equal to also 0 or 1. Now I didn't do this up above, but let's just do this quickly over here. Now if you take the square root of 1 or you take the square root of 0, those two values give you 0 and 1. So if at any point you see y is equal to 1 or y is equal to 0 on your f of x graph, it's just going to give you the same thing. So this will correspond to your x-intercepts. So you're going to have the exact same x-intercepts as your original graph. And here is wherever y is equal to 1. So wherever you see y is equal to 1 or the x-intercepts, those are going to be the exact same points on your square root graph. Okay. Dot point 3. When f of x is above y is equal to 1, the curve of r of x is below f of x. So this dot point actually corresponds to something that we did in the above. So if you have a look here, this is for this condition over here. When y is greater than 1, so when the function is greater than or equal to 1, the square root is going to be less than that. The square root is going to be less than that. That's what we saw when we took the square root of 2. It gave us a number that was smaller than 2. So here, when we take the square root of a number which is above 1, our graph of the square root of x is square root of that function is going to be below that. So here, this is if y is greater than or equal to 1, or greater than 1 actually, then square root y is going to be less than y. That's what this is telling us. So when f of x is greater than, let's just make this in f function notation. So when f of x is greater than 1, the square root of f of x is going to be below. So what this will look like is if I have my original function f of x over here and it's above 1, then the other graph, the square root of f of x is going to be below it. It's going to be below it. Okay. Next one, and I'm going to just try and speed through this. F of x is between 1 and the x-axis. R of x is above f of x. So this is the other one. This is this condition here. This is when y is between the x-axis, so y is equal to 0 and 1. what we notice is that we get a bigger number. So that is why we have r of x is going to be above f of x. Okay, so those are those 4 conditions. And we also have a bit of asymptotic behavior that we need to look at. So this is what happens when x becomes very, very big, or x becomes very, very small, big on the negative side. So if f of x goes towards infinity, so does r of x. That's the first thing. And if f of x goes to b, then r of x goes to square root of b. Now we're going to get a bit of practice doing this, so I'm going to actually apply these steps with a few examples below.